Okay, so we've established, first of all, it took us a little while to really understand where L, how L influences this graph, okay? Well, first of all, our condition is that 0 is less than or equal to P less than or equal to L, 2L, okay? So, well, that means that L is going to be a population, right? Which means that L and 2L are going to occur on the population axis. So we put L here, we put 2L here, now we've got the domain in which we want to apply this model. It's not going to apply above here, it's not going to apply below here. Of course, below here would imply a negative population, and that wouldn't occur in the current model. You could certainly have a population greater than 2L, but if you're talking about fish in a tank, if you go too much population, the fish aren't going to get enough oxygen, they're all going to die. Or most of them. So the population is going to crash, and then it's going to start rebuilding, okay? That screws up the model. So we assume that due to the conditions of the environment, this model only applies from 0 to 2L, okay? Now, we've established that there's a scale on the p-axis that's related to our domain. And, of course, population axis is here, population axis is here. What does this graph have to do with this graph? Well, what this graph told us, first of all, was the maximum rate of increase occurs when p equals L over 2. So the question is, how are we going to depict that on this graph? Well, the first thing we need to do is determine where the points are on this graph here, where p equals L over 2. Okay, well, it certainly occurs here. Where else does it occur? Well, any other place where the population coordinate is L over 2, which would be everywhere on the straight line, horizontal line. P equals L over 2. Now, everywhere on that line, your population changes at its maximum possible rate, so let's just draw a direction field just along this line, okay? So let's just say that we choose a slope, something like this, not too shallow, not too steep, just so we can work with it, okay? And we might, for various reasons, want to make it less steep or more steep at this point. It's totally arbitrary because we don't know what our proportionality constant is, and we don't have a time scale yet, okay? The time scale, the relationship between these slopes and the time scale is going to depend on what our proportionality constant is. We'll get to that. Okay, well, okay, so how am I going to draw the rest of my direction field along this line?
Should be the same, shouldn't it?
Yeah, slopes are always going to be the same because the rate of increase depends only on p. It doesn't change with t. So, if I can draw these all more or less the same, I'm having a problem with that, obviously. At least from where I'm standing, it doesn't look all that great. But okay, there it is. These are supposed to all be the same. Okay? Now, how do we construct the rest of our direction field?